Good morning, everyone, and welcome to the CAMWorks webcast, February 2009. The title of this webcast is Cutting Out the Middleman, and I'll get into that a little bit more about what that means and how CAMWorks can really help streamline your manufacturing process. But first, I want to talk just a little bit about GoEngineer. I got a couple slides here for those of you that might be new to GoEngineer, or this is the first webcast that you've seen. And I really wanted to start out by talking about our mission statement. Really what this says is, we consistently help our customers outperform their competition. And that means that we don't just sell you software, we help you with your design process, with your product data management process, your file management, things like that, to achieve really better than anticipated results. Getting design software is one thing, but we really look to supply the whole package. And here, this is where we talk about that a little bit. We believe in the pulling it all together approach, which basically means a company isn't made from just their design software or just their manufacturing software. Really, it's a whole package that works together, from SolidWorks to CAMWorks, simulation, which used to be called Cosmos, now it's referred to as simulation, and product data management. And we really help tackle those critical business issues for our customers. So we're not just a software company that just sells software. We really work with our customers to really help them be more efficient in the way that they design products, the way that they organize their files and organize their business pretty much, and the way that they manufacture. And just here you can see that we're authorized resellers for not just SolidWorks and SolidWorks simulation, but also CAMWorks, Enterprise Product Data Management, which you'll hear referred to as Enterprise PDM. We also do Oracle and Z Corp 3D printers. We offer a lot of things to our customers. One thing we offer is training. We have certified instructors for all the products that we sell. We do on-site trainings and jump starts, which will come in and show you the best practices that we've seen work for our customers in the past. We come in, whether it's SolidWorks, CAMWorks, product data management, will come in, will help jumpstart those processes for you. And we also have a great technical support team. They're located up in Salt Lake City. I think at last count, I believe there was 12 to 16 certified support technicians in Salt Lake City that are an 800 number away. And the nice thing with going with GoEngineer for your software is that it's one number. One number gets you support for your CAMWorks, for your SolidWorks, for your simulation, for your product data management, everything. You just call GoEngineer and we're there to help you. We've got experts on staff for all of the products that we sell. We have a bunch of different locations. Our main office is in Salt Lake City, Utah. We have up and down the West Coast from San Diego all the way up to the Bay Area, Sacramento. We have an office in Idaho and then one in Denver, Colorado. If you have satellite offices or different offices around, definitely have a local office, and that's key for support and for training. We have training at all of our facilities, and we have technical specialists at each facility that can help you with these products. All right, so now let's talk about cutting out the middleman and exactly what that means. Really, from birth to earth, it's design and then some validation, some kind of prototyping, and then manufacturing. Well, really, there's this disconnect between design and manufacture. And what we're seeing out there is, you have to go from your design in SolidWorks to some outside CAM system and then have it manufactured. Well, that's an extra step in the chain. That's an extra link. Really, the best case scenario is to take that part that you've designed, that you've taken time to design in SolidWorks, and manufacture from that model. No translation, no saving files as special formats. And really, when we bring this together, when CAMWorks brings this together, not only are you designing on the model that was created, but all of the updates, all of the changes in that model are automatically reflected in that manufacturing model, in that CAM model. So here's an example. Now, when I was preparing this webcast, I thought, I need to convey to everyone that I feel your pain. I've been there. I'm a machinist, and I've been there. But what I don't want to do is show the frustration in length, because all it's going to do is get everybody frustrated. But I just really want to quickly go over some of the processes that maybe some of the engineers out there don't realize, and explain to the engineers what the machinist needs and vice versa, and explain to the machinist what the engineer has to go through to do changes. So if you look at your screen here, there's a part, it's designed in SolidWorks, great. So how does this get done? How does this turn into an actual physical part? All right, we design the part, then you have to program it for machining, and this is the way you have to do it. You have to take that part in a third-party CAM software. This isn't in CAMWorks. This is in a third-party CAM software or an outside CAM software. You have to save it in a format that it can read. Maybe it reads SolidWorks files. Maybe it doesn't. Maybe you have to save it as an IGES or a Parasolid file. You have to take that. It translates the data, and then you have to save that data. So now you have your SolidWorks file and you have a machining file. Well, right there you've lost some associativity. But that being said, it goes to your machinist who's using some other software, whatever it may be. He programs the part, generates G-code. Okay, that's fine, right? It's kind of the way it goes. That's fine. Now, what happens when there's changes? So it really depends on where those changes occur in the link. So let's say, for instance, the machinist had to make the changes. There was an undercut that he couldn't cut, or there was sharp corners that he knew were going to be radii. So he calls the engineer and says, hey, I can't do these sharp corners. We can get it EDM'd maybe, but if you want this on the CNC machine, we can't do it. So if the machinist had to make the changes, really what you would want is to take that data that he has and bring it back up into your design software. Well, realistically, you can't do that, because once you save that file out as another file format, it loses all associativity. So let's say the engineer makes the changes. So if the engineer makes the changes on the model, he calls the machinist and says, hey, there's changes on this part. Well, guess what? We have to go through this whole process again. They have to save it out. They have to bring it back into that software specific file format that they can read, and then he has to regenerate the G-code for that part. This is where a lot of time is lost in the manufacturing process. So let me show you how it works with SolidWorks and CAMWorks working together. So we have a part here. It's designed in SolidWorks. Fantastic. All right. Well, with CAMWorks, we can go straight from that model in SolidWorks to CNC. And the way we do that is we design the part, and we actually program that part for machining. Now, it's either the engineer that does it or the machinist. The machinist will have a seat of SolidWorks with CAMWorks running inside of it, where he can actually take that model and lay toolpath on it. And right from SolidWorks, they can generate G-code right from the SolidWorks window. So what that means is you really are cutting out the middleman. So here's the changes. So now there's changes. Where do the changes occur? If the engineer makes the changes, those tool paths are automatically updated for that machinist. For that model, if a radius changes, if a size changes, those tool paths are automatically updated. Not only are they updated, but when you save that file and open up that file again, all of your existing tool paths that you've already done are already in that model. So if there's a hole that's added, or they put in a pocket somewhere, all the tool paths that you've already done are there. All you have to do is add the changes. So let's say the machinist had to make the changes. Again, being a machinist, I've been there a lot. I look at a part and I say, that can't be machined. I can, but there's that saying, good, fast, or cheap, pick two, right? We can do anything as machinists. It's just a matter of time and money, right? We can send something out to get it water jet or EDM, wire EDM, whatever the case may be. But realistically, we know what the engineers are expecting. So we make changes to the model, no big deal. That model is automatically updated for that engineer. So if you call the engineer and say, hey, I need to put radii in these corners, say, okay, go ahead. As soon as they do that, the next time that engineer pulls up that model, those radii are going to be there. So really, what does the integration into SolidWorks mean when I say CAMWorks is integrated into SolidWorks? Well, first of all, it means you never have to leave the SolidWorks window to generate a toolpath. So everything is done within SolidWorks. You have the full capability of SolidWorks the SolidWorks CAD, and you have the full functionality of a really robust and slick CAM package. CAMWorks uses the same SolidWorks geometry to generate the toolpath. This is key. SolidWorks is, some of you are SolidWorks users out there. As you know, SolidWorks takes a lot of time and effort to make things very easy it makes it very easy to make complex parts. So when you make these complex parts, you're using that same geometry. There's no translated into a surface model. There's no, shall I say, dumbing it down for other CAM softwares to read it. Also, the file transfers. And I'm going to get into this a little bit in the demo. The time-consuming file transfers are eliminated. And that means if you have to save it out as an IGES file, as a Parasolid file, any array of an STL model, things like that, that's totally done, that's gone. You don't have to save these out in any special file format. All of the machining is done on the SolidWorks file. CAMWorks offers what's called true associative machining. And that means when that model updates, because you're machining on that model, all of your toolpaths are going to update too. Now, the way some CAM softwares work is they say, oh, we're associative with SolidWorks. We're associative with SolidWorks. Well, the other CAM softwares that I've used, the way it works is it's not truly associative. What it does is it makes some pretty good guesses of what the geometry is. And I think if any of us, or any of you out there, me included, I've run into this, is that it's okay, but really there's a lot of work that needs to be done when a new model comes in. Also, it automatically accommodates changes to the part model, and that was what I was getting at with the last one. If there's changes to the model, the toolpaths are already going to update. It really eliminates consuming CAM system rework due to design updates. So, you have a Rev 1, Rev 2, Rev 3. If those are saved in configurations in SolidWorks, you can automatically just machine those configurations in their own window in that same file. So what you don't end up with is a separate CAM file for configure 1, configure 2, configure 3. I'm sure we've all been there. You have 2 or 3 different versions of a part. Each one of those versions of the part takes up a whole file with a file name, its unique toolpath, things like that. In CAMWorks, you can do those configurations right inside of SolidWorks. And I've run into a couple people lately that said, well, CAMWorks is great, but it's just an add-in into SolidWorks. That's absolutely, well, it's true, it is an add-in, but it's much more than that. It's a fully functional, robust machining solution. Milling, turning, wire, mill turn. It has dual spindle on turning, multi-axis, 4 and 5 axis. We do very complex machining inside of CAMWorks. So even though it looks really easy and it is very simple to use, don't think that, oh, it's just a toy. It really can't do what I need it to do. CAMWorks is a fully functioning CAM software. Okay, so now I'm going to get into the CAMWorks demonstration. I got a couple parts here. Really what I'm going to show, and I'm going to do this in a way where hopefully you don't feel frustrated, but hopefully you're going to look at this demonstration and say, hey, you know what? I go through that every day. So I'm going to just bring up a couple examples using a couple different CAM softwares and how you have to transfer files back and forth to get files in and out of those. And I have a feeling, if there's engineers listening and watching and machinists listening and watching, you're going to see a little bit of both sides of this. You're going to say, oh, I guess I didn't realize, what it took to save this model out. And the machinist will say that, where the engineer will say, oh, I understand why he needs this, X sub T or Parasolid file. Now I'm going to try and do this as streamlined as possible, so bear with me. And one thing I'd really like to say too is that, I'm certified in CAMWorks. I'm actually certified in a couple other CAM softwares. I'm not an expert at all of them. So when you see me do a couple things in other CAM softwares, please understand that, I'm doing the best I can with those, but I'm definitely not certified in them. So you might be familiar or recognize some of those CAM softwares, and you might say, oh, well, hey, there's an easier way to do that. There very well might be, but the idea behind it is that there's extra steps involved, and I just want to show you those extra steps. So let's go ahead and get started. Here I have a part that's out of the samples folder that ships with SolidWorks. It's a standard SolidWorks part made in SolidWorks. I've loaded CAMWorks. You can see here I have my CAMWorks tabs. And in 09, I have this tab up here that says CAMWorks with all my icons. Now, as a machinist, I can see that I'm not going to be able to do those sharp corners, and I know what size those holes are. As an engineer, what I can do is I can run this DFM Express. What this does is this checks the model for standards, for machining standards. And it's going to flag a few things. It flags, it checks it against some standards. Like, for instance, standard size holes, flat bottom holes, for instance. Here's one that says it's a flat bottom hole. Does that need to be flat? Can I do it with a drill? Things like that. It checks it against a set of rules. And if it breaks the rules, it flags them out. Now here you can see it saw those square corners. And another thing also is standard hole sizes. For instance, if there's a hole that's not that doesn't conform with the standard drill size, yeah, you may be able to interpolate it depending on what the hole is. What we need to do is we need to find out if they really need those holes that size or not. Now, if you have SolidWorks 2008 or 2009, you have DFM Express. It ships with it. You can run this on models kind of as a check before. But let's say they didn't run this, so now we need to machine this. Okay? So we're going to take this model and we're going to go ahead and open it up in a CAM software. So now I'm in a whole nother window. This is an outside CAM system. I'm going to go ahead and open this up. And it says that this CAM system says it'll open up SolidWorks parts. But when I do it, I get this warning. The reason this warning comes up is this software, and this is the latest version of this CAM software, it's not up to date with the Parasolid kernel that SolidWorks uses. So it says, hey, I can't open up that SolidWorks file. I don't know if a lot of you have experienced this or not. This is what I've run into. So what the engineer needs to do is to save it as a Parasolid file in an older version of Parasolids. Right there, that's a pain in the neck. The machinist says, hey, I can't open that file. You have to go back to the engineer. The engineer has to come in here, save as, pick an older version of Parasolids, and then save it out as another model. Now, right there, we've lost associativity to a certain extent with the SolidWorks model. So I've saved it out. So now I'm going to go ahead and open that Parasolid file. So right now, I've broken the associativity. Any changes that are made are not going to reflect in the other model. All right, so let me just go ahead and search for that. There we go right there. So I'm going to open this up. All right, so it opens up in wireframe mode. Pretty common for CAM softwares. That's fine. I'm going to go ahead and shade it. I'm going to come around. So now, let's say I didn't run that DFM. I'm a machinist. I see this for the first time. I see those square corners. I talk to the engineer, and he says, you know what? I need radii in those corners. No problem. I'm going to go through my CAM software and put in those radii. Now, admittedly, all CAM softwares outside of CAMWorks, of course, have their own CAD system. Now, you can see what I have to go through to create these fillets in the corners. Okay? So I'm going to go through and put some fillets in here because I know that they're going to end up in the model anyway. I talked to the engineer. He said, go ahead and do it. So there we go. We've got all the fillets in there. All right. So meanwhile, while I was doing that, the engineer noticed, wait a minute, this hole size is wrong. I want to make this a standard hole size. So I'm going to make this a 128, which is a number 30 drill. Okay, great. So in parallel, while the machining is being done on the part is changing. So now the engineer makes a frantic call to the machinist and says, hey, wait a minute, I've changed those hole sizes. So now he has to go through that same process again. Save as a Parasolid, go through, double check that the Parasolid version is correct, that they can open up. We're going to click OK and go. Now, I haven't put toolpath on the part, but if I did, as soon as I open up that Parasolid file, I'm going to have to do all that stuff over again. All right. Here we can see that there's a radii in the corner. There's a fillet in the corner. We changed that dimension. Now, let's say, for instance, this is something that the engineer forgot to tell you that changed. So when you make the toolpath or bring the new part in and look at it, you may not notice that radii has changed. So right there's a breakdown in communication. This is the middleman. This is going to the third-party software. Let me pull that up really quick. I'm going to open up that file again, and you can see here that, okay, I've got the radii in there. That's great. But you know what? The hole sizes didn't reflect. So now I'm going to have to go ahead and open up that model again and say, okay, something changed in this model. I'm going to go ahead and open it up. Now, because I made those inside fillets inside of this software, you can see that once I open up that X sub T file, that Parasolid file, they're not there. This is an issue. So every single time there's a change, you have to go through and add those fillets again. Or go back to the engineer and go, hey, you need to put those fillets in, which is more work for the engineer to do. So let's see how CAMWorks would deal with this. So whether this is the machinist or this is the engineer, I'm going to go ahead and put these fillets in SolidWorks. You can see how easy it is in SolidWorks. Say, okay, there's my fillets. That's great. The hole sizes we're going to say are good. I just click on the CAMWorks tab, and I'm ready to create toolpath. I'm going to generate a setup for this. I'm going to pick a plane that's normal to my z-axis. I'm going to say, okay, what do I want to machine? I'm going to put in a 2.5 axis feature. I'm just going to concentrate on that pocket right now. Say, okay, this is how high I need it. Perfect. I'm done. There's my feature. I generate my tool path. There we go. All right. So there's the pocket. That's as easy as it is in CAMWorks, whether the engineer makes the change or the machinist. So now let's say, oh wait, those fillets, they need to be a little bit bigger. Whatever's fitting in there, it's going to hit the corners. So we need to go ahead and change those fillets. So what I'm going to do now is I'm going to go through and change the fillet, and I'll show you how the CAMWorks automatically updates. So I'm going to go ahead and change those fillets really quick. It's as easy as just editing the feature. I'm going to go ahead and change the radii there, make it a little bit bigger. Say 50, that's good. All right, model's changed. So what that means is the actual model has changed. When I click this button, you'll see it says, hey, do you want to update this? I'm going to say, yeah, I just want to update the toolpaths that I made. And you can see that the toolpaths automatically update. So whether the engineer does it or the machinist does it, those updates are automatic. Now, one thing that I ran into when I was doing this demo was changing the part 0, and I forgot how cumbersome it was with other CAM softwares. Let me show you how we do it in CAMWorks. We just double-click on the setup. Let me move this over so we can see it. I can pick a corner where I want my G54, E1, or whatever the case may be. I can pick a vertex of where it's going to be. There's no flipping the model. There's no turning the model around. Some of the software that I was in, they said they added a new tab to automatically move the model to part 0. Well, you move it, but then you have to rotate it. It can take good 15, 20 minutes. Here I can say I can rotate it around. Here's my new x-axis. Here's my new y-axis. Here's my 0 point for machining. I click OK, I regenerate my tool paths, and that's as easy as it is. Now, 6 months from now, or a year from now, or 2 years from now, when I pull this part up, it's totally updated. I don't have to worry about what the newest version is. Are the fillets in there? Are the holes the right sizes? If I pull up a new file, my zero's already set, and it's ready to be machined. Here's another thing I kind of take for granted when I use CAMWorks and SolidWorks is be able to work on 2 files simultaneously in the same window. I don't need 5 windows open to work on a model. I just come here and I say just switch windows, and I can say here, oh, this is what's in the background, and it's all within the same window. So I don't end up with 5 or 6 different windows of my CAM software open because I'm in the middle of machining 5 or 6 different parts. So before we get into translating this into another CAM package, I just want to show you how easy this would be to program inside of SolidWorks using CAMWorks. So I'm just going to go to CAMWorks here. I'm going to press this button that's automatic feature recognition. And basically what this is this extracts all the 2-axis features that it can find. Holes, slots, pockets, perimeter features, things like that, and automatically applies toolpath to them. Now, you absolutely have the capability to modify these. This isn't what you're locked with. You can modify these. Here are all the toolpaths. Now here's something interesting. Let me flip this over really quick and show you that it actually made 2 different setups, because on the first setup there's countersinks, but there's also countersinks on the bottom. And mentioning those countersinks, you can see that it automatically put in a center drill, and countersink for each one of those holes by pressing that button. And again, you're not locked to this. People think that, oh, well, it takes over my computer and it takes over control. That's absolutely not true. You can modify these toolpaths. You can delete them. You can rearrange them. You can do whatever you want to them. Okay, so let's go ahead and open this up in another CAM software. So I go ahead and I'm going to say open file here. And when I open the file, let me find it. There it is. I'm going to get a warning here. And it says, hey, wait a minute. This isn't an older version. I don't know why it says it's an older version, because I did it in 2009. It's about the newest one out there. And it says contact support. Well, this means that it's not going to read a native SolidWorks file. I'm going to spare you the agony of going through saving it as X sub T, and just open up that same Parasolid file that I used for the other one. I actually have already saved this one as a Parasolid. So let's go ahead and open up this up as a Parasolid. So we can see we rotate it around. Looks pretty good, right? It's a pretty good translation. It's not too bad. Now, you can see on this part, my G54, my 0 is in the wrong place. So what I need to do is, in this particular software, I need to create a brand new view using 3 points. Let me pick this one. I'll pick this one. And let me pick this one last one. And then I need to tell it where my G54 is going to be. It's going to be in that hole. Fine, easy enough, that's great. Now the problem with that is that's not parametric. Where that exists on the model is not tied to the SolidWorks model. So let's go back and let's go ahead and change that model really quick. I'm just going to change this outside radius to 4 inches instead of 3. We can see that it looks completely different now. Basically the same part, same features, just spread out a little bit more. Okay. Now I'm going to go ahead and I'm going to save this back as that X sub T. Again, this is the frustrating part for both engineers and machinists. Hey, I made a modification of the part. You have to remachine it. Okay, you need to send me a file. Okay, I have to go back. Now what do you need? Oh, I need a parasolid, X sub T, and IGES file, whatever the case may be. So I'm going to go ahead and I'm going to click on here and I'm going to say Save As, and I'm going to select my parasolid. Now again, I could do an IGES file, but giving the other CAM system the benefit of the doubt, I'm going to use a parasolid because it's a little bit more associative. So right here it says the model changed. Great, let's update it. Let's do it. We click Update. You can see, look where my part 0 is. It stayed in the exact same place. So even though the model updated, changes that I made inside of that software that are unique to that software and unique to that machining will not update. And what that means to me as a programmer is now I have to go back, recreate that view, even if it takes a minute, 2 minutes, over a course of a day or a week. That's a lot of time. Okay, so let's go ahead and let me show you how this works if I did this inside of CAMWorks. So let's open up CAMWorks. I'm going to run automatic feature recognition on this part. We're going to get all our tool paths. Everything's going to be great. Now as I go down these, you'll see that that middle pocket isn't machined out. So I think this is a really good opportunity to show the wire capabilities of CAMWorks, at least touch on it and let you see what it can do. All right, so when we simulate this part, you'll see everything looks great except that middle pocket's not cut out. So I want to do it on the wire because there's sharp corners. So what I can do is I can create another configuration, a CAMWorks configuration. A configuration is the same part, just a little different. So I'm going to say I'm going to make a new configuration, and I'm going to call it wire. And this is a configuration inside of CAMWorks. I'm not making a SolidWorks configuration here. I'm going to rename this wire so I can tell the difference between them and which one's my mill and which one's my wire. Now all of my milling operations are still there. They're in the other configuration. All right, so to do the wire, I just come in here. I say, okay, I don't want to do this on a mill. I want to do this on a wire machine. Let me go ahead and select that. Great. So now I need to tell the wire machine where the top surface is. So I'm just going to say this is the part that's pointing up. Fantastic. I could use automatic feature recognition for this, but I'm going to show you how to do it manually, just because it's pretty simple to do. I'm just going to go ahead and click the path that I want that wire to follow. I'm going to insert that feature. I'm going to generate my toolpath for it. There we go. And now you can see there's my wire path. It's a little weird to see, but those red squares are where it starts and ends. Let me show you in simulation really quick. So there it is. It's doing a couple skim passes. If you'd like some more information on wire, please feel free to contact us. There's a lot more functionality that I don't have time to get into now, but you can see that it's really, really easy to do. Let's go ahead and get rid of that part in the simulation. And then there's the wired pocket. Okay, so now going back a little bit, I want to move the 0 on this part again, right? So there's my mill. All my mill stuff's still there. It's in my other configuration. I'm just going to go ahead and click on my mill. And for this setup, let's say I want to change my 0 position. Instead of being in the center of that hole, I want it somewhere that makes a little bit more sense. Let me move this over so we can all see what's going on here a little bit. So I'm just going to say, you know what? I want it in the corner of my stock. Now the stock you can define to be any size. Out of the box, it uses the default X, Y, and Z's. So there we go. So I changed the 0 position for my part. Now let's go ahead and I'm going to show you here. I'm going to go ahead and I'm going to machine this. Now I'm going to save this as an STL model. The reason I'm going to do this is I can save this graphic that you're seeing on your screen, and I can use this to verify my wire model. So I'm going to go ahead and double click on my wire. I'm going to change my stock, and I'm going to say instead of a box, I want to use an STL model that I've already created. So I'm going to go ahead and search for that STL model. There it is. Let's click OK on that. So now you're going to see when I simulate this, I'm going to have that model from my milling already there. Okay? And it's going to show me where that wire is in relationship to the part that's already machined. Not only is this key for second ops, turning, wire, things like that. This is also really good if you're machining castings. You can save an STL model in the shape of the casting and use that. Let me clean this up a little bit so we can see what's going on. Let me delete that middle part there. Let me get rid of this tool too. Let me flip this over. So that tool's kind of in the way. I'm just going to go ahead and hide that. So you can see there's the wired part there. So this is a real good graphic representation of what you're going to end up with at the end of the day. And that's about all the time we have for the demo today. So I covered a bit of material today. It's kind of hard to convey pain to the customer that you guys might be feeling and not have you relive it. I didn't want you to get frustrated while watching this, but hopefully I was able to convey to you that there are definitely issues when you use outside CAM software that CAMWorks definitely alleviates. There's a lot of advantages that are kind of hidden. Sure, it's functional, it's fast, it's a very robust, big package, but it also helps the productivity overall, and it really closes that gap between design and manufacturing. You may be saying to yourself, so, hey, this is great, it's fantastic, but you know what, I've already got a CAM system. We've got a lot of pricing that's very, very affordable. There's no cost extended term financing, which basically means 0% financing. It's valid for CAMWorks and SolidWorks. We can do it for trainings and jump starts and maintenance and stuff like that. That's a very helpful thing. Now, here's the key one. CAMWorks offers conversion pricing. So if you already have a system, you've already invested X amount of dollars in a system, and gee whiz, I don't want to start from scratch again. What we can do is if you're converting from another system, we have some very, very, very good pricing for you to convert over. And if you have any questions about that, pricing or technical support or anything, you can definitely visit our website at www.goengineer.com, or feel free to email me. My email is on your screen, cmacbain@goengineer.com, or you give me a call, 818-438-1284. You can also call any one of your local GoEngineer offices or sales professionals. They have all this information. Thank you very much. Thank you for your time, and I look forward to working with you in the future.